Oh, beautiful. Cheers, Grant.
Oh, might go to the next one. All right. Hey, welcome everybody. Kia ora e Stefano. My name is Emily, and this is
Alan.
Stefano.
Wow. Cool.
Wow, that was exciting. That was exciting.
There we go. So, can anyone make a prediction from that little mistake of how much delay there is when we watch this on our camera? Anyway.
Yeah, that's good. Hey, it's great to be here. It's Saturday.
Whoop, whoop.
For those people who don't know what day it is, that is my PSA for today. It's Saturday, and that is why I'm in my slippers.
Slipper Saturday.
Slipper Saturday. I think it might also be Slipper Sunday because we have made a commitment to go live every day pretty much for the whole of this lockdown. So it's good to see you here. We appreciate it. As I said before, for those people that logged on early, please subscribe. Bit gutting out. I'm getting over it, to be fair.
Is Maze bringing us apples? Apple would take
Maze has
for the
got trees.
teacher. There you
Yeah,
go.
apple for the teacher. Love it. Hey, we're a little bit gutted today, but we got over it because it's how we roll in our bubble. You just got to get over stuff. We did really want to go outside today to do the classic fizzy drink Mentos experiment because I'm not cool making all that mess in the garage. But we actually need 1,000 subscribers to go outside on our mobile phones. At the moment, we're doing YouTube from our laptop. So that's all cool. I'm thinking by next Saturday. Oh no, we're actually having a break over Easter.
Yep.
Shh, don't tell anyone. But I reckon Alan has made a commitment to any time, day or night, that we hit 1,000 subscribers. Alan, even if he's in his pajamas, is gonna go outside and do the Mentos and fizzy drink.
Might just kind of revise that a little bit.
Alan, that's what you said yesterday.
Yeah, but you know, we all say crazy. I was having cabin fever. I was saying crazy things. What can I say? Not fever, just anyway.
Anywho, but I think it's a great idea.
Yeah.
Especially if you can just do the selfie stick while I'm still asleep. Anywho,
I'm backing out of this one.
We'll hold you to it. I've got witnesses. All right. So before we get into the science today, massive shout outs. Emily and Lee's all here. Hello, Emily and Uncle Alan. You get the status, man.
There we go.
Hey, awesome to see you, ladies. Thanks for your support. Oliver's here, of course.
He wants to know how the sprouts are going. We're going to have an update tomorrow. About the sprouts. It's very exciting.
I have watered them though. I think you're supposed to water them 3 times a day, and I only missed once yesterday. To be honest, I'm taking that as a win. For somebody that watches a lot of Netflix, there's lots I haven't got time for.
Apparently, I can't work out if they mean YouTube is lagging or the fact that this is show 14 and that. But apparently there was a bit of a lag, so we'll see what happens.
Actually, this might be show 13. Unlucky for some. Probably you guys will be fine. Okay, so today we're going to do. We're leaving it now.
Hans has just updated. He's putting shelves up in his room. I love that kind of update. Can we, when you got your shelves up and got stuff on them, can you put a picture up on our Facebook page? Because I love shelving. I just find shelving and storage and sorting stuff out.
You might think Alan's being sarcastic right now. He's really not. He just loves a shelf.
I love a good shelf.
Speaking about shelves,
do a shelving special one day.
Yeah, maybe we should do that.
Yeah, cool.
Anywho, so speaking of shelving, Alan, that reminds me of something else that sounds like shelving, but it's more fun.
Science.
No shout-outs.
Shout-outs, yeah.
Hey, I didn't get to do a shout-out. I didn't get to do a shout-out yesterday. Because I was all alone in my virtual bubble. Because nobody sent me pictures of them doing fun stuff. So obviously nobody on the planet did any fun stuff yesterday. That is a lie. You would have done some fun stuff. I really want to give you a shout out on our Facebook page. If you're doing fun science stuff or you're just doing fun shelving, send us a pic. I want to celebrate you, and I want to celebrate the parents out there because I do give #parenting awards because we appreciate you So much. So, apparently, we are going to be doing some science. So, Alan, have you got that can?
I've got in that really important storage space. There you go.
I'm loving Saturday. Alan's just going to go get the can.
I've got it in a very special place.
He's got it in a safe space that only he knows where it is. All right. So Alan's going to go get that thing that he put in the safe space, and he'll be back. But the other day we did an experiment with the can. Give me a thumbs up if you remember. Cheers, Al, you're amazing. Give me a thumbs up if you remember the can experiment. Okay, so here you do. I do take things out. Where was it? Oh, I know where it was.
Recycling. There you go.
What did it
It's
tell us?
important. Recycling is important, people. There we go.
I'm so impressed. Okay.
Just check with your local councils that the recycling is picked up on trash days, but actually goes to your goes and bees actually recycled. So just always check that out in these times. But sorry, Em.
No, you're good today. You're all
Yeah.
good. So one of our Science in a Van fans said they missed this experiment. That's all good. Go to our website and we've got all the list of all the shows we've done, and it gives you a little heads up of what we did in that show. So go back and find the one about the can experiment. So we had a can. It wasn't crushed at the time. We heated it up on a hot plate, and the can got hot. It was empty, but it had a little bit of H2O. Do you know what H2O is, Alan?
Oh, H2O. It's up here. H2O. Hydrogen and oxygen from the periodic table of elements comes together and makes a water molecule. A water molecule.
Well done, Alan. Anyway, the water molecules in there, absolutely right. They got so hot, they turned into what, Alan?
They turned from a liquid into a gas because of the amount of energy in it. Because heat is energy.
You are on fire today.
Yeah, I hope not.
I have not seen no naked flames. Okay. So, and then that was all hot and it was going all crazy, right? And then we actually turned it over and put it in some cold water, and this happened. Dun, dun, dun. It was pretty fun. It made quite a noise. So I really like this experiment, but we thought we'd do it again in a different way. So, Alan, you have got a bit of a variation on the thing.
Good work there, my friends, with calling out H2O and water.
Awesome.
That was good. I think it was Nathan, Oliver, and someone else said something about water. Excellent. So
Well
that's
done,
good. And that's awesome. So like Emily says, we're going to do a variation of this experiment.
I'm excited.
Now and then, different experiments kind of make us look at the same thing differently. So it's worth kind of having a collection of variations, and you can do. And what I'm excited about this one is we do this one in our school shows, but this one I don't get to do much. So I'm quite excited about sharing it with you today.
Oh, you got your health and safety gloves.
Yeah, we got the health and safety gloves. You'll see why in a moment. Now, here I've got a glass jar. It's a jar which was used for preserves, for jam and stuff like that. The reason I've chosen this jar is when they make jam is boiling hot sugar when they put in these jars. So I know that this jar can withstand the heat of boiling water. Okay, so
does it need to?
Well,
I can't speak. Does it need to be able to cope with hot water?
The first thing I'm going to do is fill the jar up with the boiling water from this jug. Okay?
I'm going to get the camera out.
So, yeah.
Oh no!
So,
stand back.
So what's happening here is, remember, heat is energy. Someone commented that yesterday. Beautiful sentence, very short, very precise, big bit of science. Heat is energy. Heat is energy. So the heat energy from the hot water is going into the glass, and they were heating up the glass. So the energy is being transferred, energy transfer is being transferred to the glass jar. When I pull the hot water out, as a result, the jar's still going to be hot, and the air inside the jar is going to be hot as well. What I'm going to do is just pour this away and refill it up with boiling water.
Maisie, be careful.
I want to get the jar
really
nice and hot. Thank you, mate.
Yeah,
that's very
really
kind.
nice. Oh, yeah, quite a few people say be careful, Alan.
Yeah.
Lucky he's got adult supervision, eh? Oh,
Yeah. So, my friends, I'm just doing the same thing again. I'm just heating the glass jar up because what I'm going to do in a moment, I'm going to pour the hot water away. So all I'm left with is the heated jar. As a result, the air in the jar is heated as well. I'm going to turn it upside down so the mouth of the jar is in the water. And we're going to make a prediction and an observation of what's going to happen. I just want to make something clear. When Emily moves the camera in a few moments, you will see a coin in the water. That's just to create a little ledge so the jar doesn't sit flat on the bottom.
Oh, yeah.
You don't need to worry about it. It's just there to overcome a problem I had in practice. So it's there for a reason, but not much to do with the experiment as such. So we've got the heated jar going to go down in there.
And that's cold, right?
And that's cold, yeah. I want you to make a prediction of what's going to happen. I want you to make a prediction of what's going to happen when I take the heated jar and put it mouth down into the water.
Waiting for your prediction. As you're doing that, don't ask me why the water's blue, because it's food colouring. I know somebody's going to ask that.
Yeah.
So this water's cold. That jar will be empty. We're going to turn it over and see what happens. We're waiting for your predictions. Oh, some people are saying it's going to fill up. Some people are saying maybe steam. Some people said no clue. That's absolutely fine. Cool. Oliver says it will sizzle. Hey, good good predictions.
Yeah.
The heat will make it sizzle. Oliver's asking, is it pure water? It's just water from the tap.
Yeah.
The hot stuff's been boiled in a kettle, and the blue stuff is just water from the tap with blue food colouring.
Yeah. The reason we put the blue food colouring in it is so you can see it on camera. It's very important that you see the water.
Maze has got a good clarifying question. Alan's actually going to pour out that boiling water, so it'll be an empty jar, but it'll be really hot.
Cool,
okay,
nice
so that'll be empty. Thank you, Maze, for that.
Yep.
The water will separate. Oh, I love these predictions.
Cool. Okay.
Should we do it?
Yeah.
Oh, I'll move the camera, right?
Move the camera. Get the camera. Facebookers, you're just going to have to hang there. Is anyone actually watching in Facebook?
Hey, Facebookers. Oh, Sandy is. Hi, you guys.
Hey.
Oh, there's some predictions on Facebook. Hey, Facebookers, we're so sorry we can only interact with comments on YouTube because we get really confused, as you can imagine.
So
let me just...
Let's get it on the blue water. And I'm just going to pour...
This is hard. Hang on. Oh, you pull that away.
So I'm pouring the boiling water away from the jar. The jar is now heated.
Gonna be all right.
I'm going to put it there like so. We're going to watch what's going to happen.
I see some bubbles.
Yeah. Now I'm just going to take some more water.
Cold water?
Yeah, this is cold water. Oh, can you see what's happening in there?
Oh, whoa, 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 whoa.
Yeah. So I'm just going to top up as the water moves into the jar. I'm just going to pour some more over here. And you might want to make a prediction of what this water pouring over is going to do to it. And just keep watching.
Oh my gosh, I can see it coming up now.
Yeah.
It's not really sizzling, Maze, but I can see the water coming out. I kind of wish it was sizzling. That would be really fun. That was a good prediction. Oh, there are bubbles. Good observation.
Yeah.
Some people are like, yeah. Good question, Alan. Is it taking the air out? Ooh. We're going to talk about that in a minute. That's a great question. Oliver's observed that it's sucking the water up.
Yeah.
Van's just like freaking out.
Cool.
Sucking up into the jar. It's rising. That's a good prediction from Emily or Lisa. I'm not sure who, but great prediction. Yeah, and you can see on here, Ali.
So we're just gonna hang there for a bit.
How is that possible, Oliver? Great question.
That is a big question.
It looks like a magic trick, but it's actually we can explain it with science, and we're going to do that in a minute. It might be the temperature. It's got a lot to do with the temperature. So that's really good thinking.
And the change in temperature and how the materials respond to that temperature change. That is real.
It's real cool.
Like again, beautiful, simple sentence. and I've kind of now quickly put 3 or 4 other things in there as well that makes it a bigger subject. But we're going to break it down into little bits.
And what I like about that is you're doing what scientists do every day because you're a scientist. You're moving from what you can see to explaining it, right? That's what scientists do. They move from observations to explanations. So well done, scientists. You're doing really, really good. What does that feel like now?
Yep, use the back of your hand.
I'll use the back of my hand.
Yeah.
It's not boiling, is it? It's cooled down, but it's still a little bit warm, but not like before, right?
Not like before.
I don't need oven gloves.
So there is a chance as it cools down, we'll get the water a little higher in it. But I tell you what, Em, shall we flick the camera back to position 1 and we'll have a little chat about what's happened?
Look, I'm so excited.
Because I think our wonderful friends in
they're all over
YouTube.
It. Well, some of them have done this experiment before. It is a bit of a classic.
That is a bit of a classic. But again, I said different experiments can help to explain and make us look at things differently. Also, sometimes it's just what lens we're looking at the experiment in as well. So, Emily,
yes,
you observed the water rise up in here. Yeah?
I did, Alan. It went, at the beginning, it was quite slow. To be honest, I was a bit like, is this going to work? And then it really went for it, especially when you put the cold water on top.
So, do you remember, your can experiment?
I do.
Do you remember you only put in that much water?
Yeah.
But when it crushes and we bring it out, there's a lot more water in it.
There is.
Same,
it does fill up.
It's the same thing. So
we did, because we went like that, eh?
Yeah. So when we heat the jar up, we heat the jar up, and that heats the air. So the heat energy from the water gets transferred into the jar. The heat energy in the jar gets transferred to the air around it. So the air, the gases in the air we breathe are all heated up in the jar. They're still a gas. They've not changed their state of matter. They've just got more energy. They're like, woo! Now, when we turn it upside down, things start to cool down. So the air is still a gas. It's still all those gases, but they cool. As they get cooler, the temperature lowers, they start to come closer together, taking up less volume. Same amount of mass, but less volume. And they start to take up less room. And as they take up less room, the universe doesn't like nothing, so it tries to fill it up with the water. Does that kind of make sense?
Oh, so I was just pretending to be gas without the energy. It does make sense, and I've had a little bit of a brain fart, I have to be honest.
That was the bubbles.
Because I do this experiment a lot. We do it on one of our shows called What's the Matter when we go into school. So I'm really familiar with this one. But what I've come to think about it is I can't see through the can, right? I'm not that clever. But with the jar, you can see through.
You can see through.
So even though I know that the can fills up with water and all that and it crushes, I can now visualize what happens in the can. Do you know what I mean?
That's cool.
And also, I've been thinking about, this is really sturdy. Like, this is quite thick glass, right? And aluminium's a different material. It's quite flimsy, actually.
Different properties, yeah.
Ooh, different properties. So that's why it crashed. So if this can was made out of something different, maybe it would crash. But it does depend on the materials, right? This is perfect for doing this experiment. And this is perfect for this experiment. So that was just a nice thought I had. And I kind of wish I could see through the can when I do this, but life's not like that.
Em's just kind of explained something, and something quite exciting from our angle has happened here as well. People asked us when we go into schools and do live shows, people do ask us how we keep the shows fresh and exciting. We do the same thing hundreds and hundreds of times.
How do we, Alan?
And it's moments like this.
That's true.
We look at something different. So Emily's just admitted that when she does this again, she's going to look at it through the lens of what she saw here, and it's going to add to that. And that's what we're all about. Like I say, it might look like we're doing the same experiments again and again, but we're always dropping in new information, doing them different ways, and seeing what's going on. Can I just point out one other thing?
I don't know.
People noticed that when I put the jar in, there was bubbles.
Yeah,
those bubbles are quite
exciting.
You will not believe how many scientists value bubbles in their work. It's amazing. When we put that in, those bubbles were formed by the air still heating up. It was expanding, and that's what those bubbles were. And then as it cooled down, it couldn't suck the air back in because the barrier for water. So it drew up, it sucked up the water. There we go. So
somebody had a good question. It's back up on the comments because people are loving the comments today. They're like, 20 people are watching, yay! Which is really nice.
Yeah.
But also somebody had a when we do experiments, AL, like you can change one thing to learn something new. So if you change something in an experiment, it's called a variable.
Changing a variable.
So they were wondering about the variable of the glass jar.
Ooh.
What would happen if the glass jar was cold? Now, Al.
Yep.
I know you know the answer to that.
Uh-huh.
But that is something you could try at home. What would happen if the glass jar was cold? So I'm going to leave that to you.
Excellent.
That was a good experiment, Alan.
Excellent. So let's get this table out of the way.
Because
we've got one more thing to show you. But Emily's going to run through what you need for tomorrow and what's coming up.
Oh, man, you're doing that really well. I can't stop watching you, Al. Please don't spoil it. He's doing a great job. And the table lands.
Yes.
Sorry, I could not stop watching that. That was really exciting. Okay, well done now.
If we had 1,000 viewers, I could have strapped the camera to my head and you could have watched that happen. That would have been amazing.
Alan, you're just full of ideas today. Loving your work. Okay, so team, I'm just going to turn off my phone for 2 seconds because I've got a bit wet. That's fun. All right, so tomorrow, today is Slipper Saturday. Tomorrow will be Slipper Sunday. I'm going to lead you through a bit of a thing that's going to be a bit of a chill out. Yeah, I think it's quite nice. Adults, you'll probably like it too, to be honest, because you'll end up with something that's quite nice to play with. So you will need like a plastic bottle. Doesn't have to be very big. You need some water and you need some cooking oil. Not too much because everything is quite precious at the moment, so just a little bit. And also, if you've got some food colouring, just one colour, that's all good. Or glitter, or unicorns.
Even a little bit of watercolour paint would
go
into the water.
You don't need unicorns. I just like saying unicorns. So that's going to be tomorrow. I'll put up a thing on Facebook so you remember what to do. Dory Todd's probably written that down already though. But for now, Alan, we were going to do something fun because it's Saturday. So you're going to teach me a little trick, right?
So I'm going to teach Emily a trick. In the process, you're going to see everything you need to know, and then you can spend today practicing this. We do suggest you practice this outside, away from anything that's breakable. There we go. So for this, you need some coins. I've got these giant American dollars here. I'm using these because I've got them, but any coin will do. Actually, the New Zealand $2 coin is pretty cool as well. So I'm going to teach Emily how to do this. You're going to watch and see everything you need to know, and we're going to talk about what you can add to this as well. So, Emily, we're going to take the coin.
Yep.
We're going to take our hand and put our hand on our shoulder, palm up, like so. And we're going to get our elbow out in front of us.
Yep.
And on the top of our elbow, we're going to put the coin.
Yep.
Now, I'm going to go 3, 2, 1. I'm going to take the coin away and show you what we're going to do. On 1, we're going to drop our elbow down and we're going to snatch with our hand, hopefully catching the coin in mid-air.
Hang on a minute, Alan. You know I'm quite unco, right? I know about forces. I'm thinking, right, if I catch it, happy days. Like, well done, Emily. But there is a high chance, Alan, that I'm not going to catch it. And what I'm going to do, I'm just going to push it with a force and that'll move it through the air. And if there was like a glass window there, I'd smash it and everybody would hate me.
That's why I said practice this outside, Emily. But we're going to be a little bit dangerous because we are science in the shed. There we go. So, are we ready?
Not really.
Let's get into position.
And wait, one more thing.
Yeah.
The laptop screen is right there.
That's fine. Here we go.
What, are we going 1, 2, 3, then do it, or 1?
No, 3, 2, 1. It's a countdown.
3, 2, 1, and then do it.
Then do it. 3, 2. So 3, 2, 1. Bosh. There we go.
Okay.
So
What?
there we go. Excellent. So let's do that again. Let's put it on our elbow. Let's prove it wasn't a fluke. We go 3, 2, 1. And the motion is the elbow just drops. We're not throwing it up. We're not flicking it. We're just dropping the elbow. And as the elbow comes down, almost naturally, as the elbow comes down to our side, our hand is almost in position to where the elbow was. And we just grab it.
So gravity's pulling this to the ground, eh?
So, yep. So
I'm quicker than gravity.
So our elbow moves quickly. The coin starts to fall thanks to gravity, and our hand catches.
I'm ready. I'm ready. I'm ready. I'm ready. I'm ready.
Here we go. Ready? 3, 2, 1. Excellent. You need to show the coin. You need to show the coin. There we are. Excellent. So, my friends, once you've mastered one coin, Emily's now going to try 2 coins. So there's 2 coins for you.
Oh, yeah.
There's a second. So we're going to stack the coins on top of each other.
Yeah, I can do that.
We're going to put it on our elbows.
Yep, and that.
And that. And we go 3, 2, 1, and we grab them. Are you ready?
No, I'm not ready. I can't. Yeah. No. Okay, yeah. Okay,
Here we go. 3, 2, 1.
Oh, Ellen, you must have dropped yours. Oh, yeah. I just give
And
my
again.
coins. Yeah.
There you go, get your coins.
Okay.
Here we
That's
go.
okay.
Let's
I'm
try
alright,
again.
guys.
If
Okay.
at first you don't succeed, skydiving's not for you.
Okay.
Here we go. Ready? 3, 2, 1. Oh. There. Let's try 3. Let's try 3.
This is so good.
There's do you think Em's going to do 3 first time? Do you think I'm going to do 3 first time?
And I'm thinking like a scientist today. I'm thinking I probably won't do 3.
Here we go.
I
Go on,
will
try it. Try it. We're going to go.
Oh, no, I'm ready.
All right,
Okay,
calm down.
okay.
Here we go. 3, 2, 1. I'll tell you what. Let's try 4. Let's try $4 coins. 4. There we go.
Okay.
So we'll just keep adding coins and we just keep seeing what's happening. So we're going to do 4. Here we go. And then after this, we'll do a quick wrap up of what we need tomorrow again. And then it's joke of the day.
I think with 4, I might literally just be the joke of the day.
Here we go.
Okay, hang on. I gotta balance it. Okay, I'm ready.
1, 2.
Hang on! You went 3, 2, 1 before.
All right. 3, 2, 1.
Nobody would have heard that, eh?
You going to try again?
Am I?
I don't know, are you?
Am I? Okay, I'll try again. No, genuine question. Hard to know. All right. Are you doing it, or is it just me? Okay. I think the trick is for me to turn my hand around. Ready?
Yep.
Okay.
Ready?
No. Yes. Yep.
3, 2, 1. Yeah! Pucky for Emily.
Thanks, Al. Oh, gold stars for me today.
So,
Ellen, thank you for teaching me that.
That's all
I
right.
have done this in the past, but I've never done so many. That was really cool. And it's been a long time.
Find yourself some coins or anything
really
with
cool.
a small volume and a large mass. Go outside because you will throw things away. You might want to try it different ways and see what happens. Have a lot of fun with this. It's a cool little trick to do. See how many coins you can get up to and have a good old time.
Oh, Van predicted that you do it first time.
Excellent.
That's because Van knows you. All right. People are talking about the types of variables. Yeah, try different coins, see what works for you. Really good.
Yeah.
Hey, we've done a lot in the comments today, and we were supposed to do a short show because it's Short Show Saturday. I'm just making up titles all around.
Short show Saturday in the Shepherds.
Short Show Saturday in Shippers.
Yeah.
Okay. So that could go wrong. But it is time to wrap up. Tomorrow you'll need a plastic bottle, a little bit of cooking oil, food colouring if you've got it, glitter if you've got it, whatever. We will see you tomorrow. But for now, my friends, it is time for
Joke of the day.
Drum roll, please, everybody. Here we go.
Why can't you have parties? Why can't you have parties in space?
Alan.
Yep.
Why can't you have a party in space?
Because there's no atmosphere.
That's great. We don't tell each other what the joke is.
So, my friends, we're going to cue the music. We're going to see you tomorrow. Woo! Remember your bottle, remember your water, remember your oil, and remember, turn up in your slippers or however we find you. You can see us, we can't see you, so it's all good. But we know you are beautiful.
We do.
So, my friends, peace out. Catch you tomorrow for another Science in a Van live.
Peace and hygiene. Here we go. Here's the music. Are you ready to dance, mate? Here we go. Science in the shed. Bye, Facebookers. Bye, YouTubers.